Hello ma'am, this is Yosai Krishna explaining about the topic application of finite automata in search engine. These are the contents I am going to explain. Brief overview of finite automata, brief overview on search engine algorithm, discussing the working of classic brute force algorithm without using the concept of automata, automata based pattern searching, comparing the efficiency of a string searching of brute force algorithm and automata based pattern searching, and at last conclusion, and I'll explain about the real life applications using of finite automata. Finite automata. What is finite automata? Finite automata is a simple idler machine used to recognize pattern within the inputs taken from some character set. The job of finite automata is to accept or reject an input depending on whether the pattern is defined by the finite automata occur in the input. The finite automata have five symbols. Q. The Q states that the finite set of the state and it is a starting symbol. The sum of represent the finite input of alphabets, and the delta represent the transition function from Q into sum of to Q. And S is a starting state and F is a set of final states accepting all the strings. Finite automata can be represented by input trap and final control. What is input trap? It is a linear trap having some number of shells. Each input symbol is placed in each cell. Finite control. The finite control decides the next state on receiving particular input from input trap. The trap reads the cell one by one from the left to right, and at a time only one input symbol is read. This is an example of input trap. Now I am going to explain construction of finite automata from transition table and vice versa. For example, now this is a regular expression. A regular expression is a sequence of character that defines an such pattern. Regular expression are used to match pattern in text data, and they are the powerful tool for searching and matching text. Regular expression is a combination of characters and special symbols such as plus and minus, etc. Each character is a regular expression matches of specific character in the text, while specific symbols modified in matching behavior. And in this example, Q1 is a starting state and QF is a final state. In this, the sequence is the sequence is created, that is 0, 1, 1, 0, and 1. Constructing a finite automata using a problem statement. Design a finite automata which accepts the strings 0 and 1 with the three consecutive zeros. Sample strings are 000, 0001, 1000, 10001. Now we must take four states. That is Q0 is starting state and Q3 is final state. In this string, the string accepts all the 0 and 1 possible strings. Now let's go to the topic. Brief overview on searching algorithm. One of the most common problem involving string is that of searching for occurrence of the given pattern as a substring of the large text string. Text is one of the most widely used media data type in research and development for information retrieval and data mining. String searching algorithms are the algorithms that are designed to search for occurrence of string in a large body of strings, and these algorithms differ in their time complexities and efficiency of operations. Before the advent of these classic string algorithms such as cramp, RAM, etc., brute force algorithm was in the use to find the interference as timing constraints is a measure when they take about all the algorithms. Working of brute force algorithm without using an finite automata. In brute force manner, the string matching algorithm compares a pattern character by character in each and every location of the text. Starting at the beginning of the text string, the characters of the pattern is compared one after another with the corresponding characters in the text until a mismatch is found or the complete pattern is searched executively. If the pattern is excited, then a match is said to have been found at the beginning of the text. If the mismatch of character is detected before the pattern is excited, then the pattern does not occur at the beginning of the text. The matching is started all over again at the next character. The text and the same procedure is continued repeatedly. And these finite automata can work off a brute force without using an automata. Algorithm. Comparing pattern to the text, well, pattern symbols is less than the text symbols. The first step is if a first symbol of pattern is same as first symbol of text, then an increment pattern on the text to next symbol of pattern and next symbol of text repeatedly and check again whether they match. And next, B continues as long as successive increment of pattern matches successfully increment of text until end of the pattern is reached. And announcement match success. If first symbol of pattern is not same as first symbol of text, a shift pattern down text to the right by one position of the first symbol of the pattern assigned with the next symbol of the text and check again whether they match. If continuous of 2 continues the before step as long as subsequent shift of the pattern it does not match the successive increment of the text until the next excited and announcement match is failure. Example of brute force search algorithm. Now let's take an example of a sequence of alphabets that is text and pattern is ACBA. Now let's compare with the text. Now A does not match with C. So now it is not matching at the first. So move to the next iteration. It is step 1. Now let's go to step 2. In step 2, A matches with A and C matches with the C and B does not match with C. So move to the next iteration. In second iteration, A does not match with C. So we cannot match even third iteration. Now let's move to the next iteration. In next iteration also A does not match with C. So at the sixth and it moves so on. At the sixth iteration, A matches with A, C matches with C, and B matches with B, and A matches with A. Now the pattern is matched successfully. This is a brute force example of this brute force. Now, the next topic is automata based pattern searching. We will discuss the finite automata based pattern searching algorithm. In a finite automata algorithm, we pre-process the pattern and build a 2D array that represents the finite automata. Construction of the finite automata is the main tricky part of this algorithm. Once the finite automata is built, then the searching is simple. In search, we simply need to start from the first state of the automata and the first character of the text. At every step, we consider next state of the text, look for the next state in the built finite automata and move to the next state. This is how we process the automata based on patterns searching. Construction of automata for a pattern text. A text is given is a sequence of alphabets and pattern is BCABC. The first prepare the transition table of a pattern for the identical use of A, B and C. To identify number of states required to construct the finite automata, as there is a 5 states in the pattern, we need to be searched. We require 6 different states in our own automata. The 6 states are S0, S1, S2, S3 and S4, S5. Now by using this table, we can construct an finite automata. Transition from S0. Except for the input B, the transition will be able to do. Transition from S1 for A, B and A. B does not belong to A, so no equal strings. So fill S0. Now let's go to B. So B and B is equal to B. String of length 1 is equal. So fill S1. For C, already the filled while constructing the enough finite automata. Transition of now let's go to transition for S2. For A, already filled with the constructing of a rough finite automata. For B, BCB and BC does not belong to CB. So B is equal to B. String of length 1 is equal to the S1. For C, even for C, BC is not equal to CC. So B is not equal to C. So no equal. So fill S0. These are the transition of S3 and S4 and S5. Now let's take a sample string of finite automata and scan each alphabets in the sample string and move forward. The next states or not. If we research final state of automata on scanning each alphabets of the string is accepted and pattern or something is matched. Comparing the efficiency of string searching of brute force algorithm and automata based pattern searching. From this experiment performed, the brute force algorithm approach required the input text string to be backupped whenever there is an unsuccessful match with a symbol in the pattern. This problem of backtracking raises the complement of time, the algorithm. Backtracking is a phenomenon where the text string jumps to the next position whenever a mismatch occurs at the result of a mismatch occurred. It can be otherwise be said that the text that can be shifted to the required order to the next text symbol can be compared with the pattern. This is a quadratic order that the brute force algorithm is very slow. On constructing of a start diagram or the start transition table of the finite automata of a pattern, we can scan that the text is searched for pattern by comparing each text symbol only once, not requiring any backtrack when there is a mismatch. Hence, we can find all the occurrence of a pattern in the text length. The time is significant and different of a DFA string. Searching method is compared to the brute force approach. Now, at last, this is the real-time applications of a finite automata in search engine using an above concepts. For designing a legal analysis of complex compiler, for recognizing the pattern using a regular expressions used in the text editors, for implementing for spell checkers. For instance, we are all searching for a word car. Suppose the word car is some documents, we can build a finite automata to find a car very quickly in the document. Similarly, we try to search any word. Our search engine creates a finite automata and runs through a similar type of text. If there is a text reaches to the final state, it is displayed as an suggestion. Thank you.